All right, so let's go ahead and start this next set of notes for lesson 3.6. We're going to be looking at finding more zeros and how to get something in standard form. So there's a lot that we're going to be looking at. But first, I want you to start by looking at this warm-up. And so it's important that we review the quadratic formula. So I added the quadratic formula into your notes here if you want to add that into yours. But I want you to pause this video and I want you to practice doing this quadratic formula for x squared minus 7x minus 18 to figure out what the roots or zeros would be for that quadratic. So go ahead, pause the video, use that quadratic formula to get some practice in, and then hit play when you're ready to check your answer. All right, I already have it all worked out. You should get -2 and +9. So the way that you set that up, or you start by setting that up in your quadratic formula and find the discriminant. So make sure you get all those pieces in the square root correct. Now -7, when you square that, would become a +49. So make sure you didn't make a mistake there. So always square the b value. Don't just write it down as -7 squared, because otherwise if you type that in your calculator incorrectly, your calculator is going to give you the wrong answer because you made the mistake of how you typed it in. So just go ahead and square the b value. So -7, you know, would square that would be a +49. -4 times 1 times -18 would give you a +121 under the radical. So your discriminant is 121. Now the square root of 121 is 11. So we're going to have our two answers. One where we would take 7 plus 11 divided by 2, which would give you 9. Because 18 divided by 2 is 9. And then the second option would be to take 7, or the second solution would be 7 minus 11, which is -4 divided by 2, gives you -2. So our two solutions would be -2 and 9. So that's just a review of the quadratic formula. Let's get into what we're going to be doing today. So the first thing that we need to understand is what's called the conjugate root theorem. All that tells us, or all that is that if they tell you that a plus bi is a 0, then its conjugate, a minus bi, would also be a 0. So what does that mean? Well, we can use that to get something write something as a quadratic. So let me take this first example. So it says write a quadratic function in standard form with 2 plus 5i is one of the roots. So they gave us 2 plus 5i as a root. So that means the other root is its conjugate, 2 minus 5i. Now, if you're wondering why we're using the word root here, what does that mean? It's just another term for a 0. Okay, so root and 0 those terms are interchangeable. All right, so if one root is 2 plus 5i and the other root is 2 minus 5i, we can start by writing this into factored form. So remember, factored form, we would just take x minus each root. So x minus 2 plus 5i and x minus the other one, 2 minus 5i. Well, that's factored form. They want us to write the answer in standard form. So to get this in standard form, we're just going to multiply these two together. So we're going to take and set up a 3 by 3 grid. We have x minus 2 plus 5i, x minus 2 minus 5i. Now watch what happens. X times x is x squared, x times -2 is -2x, so far nothing too extravagant. When we multiply x times 5i, let's put the variables last, so we'd have 5ix, and then go to the next row. So -2 times x is -2x, -2 times -2 is a +4, and -2 times 5i would be a -10i. All right, so again, nothing too unique, but let's look at this last bottom row. -5i times x, we'll write that as -5ix. -5i times -2 would be a +10i. And -5i times 5i is -25i squared. Now let's simplify what we have in the box here. So let's look at a couple of things though before we start to combine like terms, because 5ix minus 5ix, those are opposites of each other, so they cancel each other out. These are opposites of each other, they also cancel out. Now I squared, remember I squared is the same as -1. Okay, so we have -25 times -1, that's a +25. Okay, so that bottom right corner is a +25, so don't forget to combine that with your like terms here. So now inside the boxes we combine like terms, so we have, so I'm going to write this in standard form. So we would start with x squared, and -2x plus -2x would be -4x, and 4 plus 25 is 29. So that's how you could represent that. So if we were to solve this, if I were to take x squared minus 4x plus 29, and if I were to use a quadratic formula to find the zeros, I would get 2 plus or minus 5i as my answer. All right, I want you guys to take this same concept that we just did and find the quadratic in standard form where 2 minus 3i is one of the zeros or one of the roots. So do what we did first in pink. First identify what the other root would be, then set it up in factored form with what I did in green. Multiply those together and get your answer in standard form, what I did in purple. So do all three parts. And so pause the video and hit play when you're ready to check to see your answer. All right, so in this case, your other zero or your other root would be 2 plus 5i. Okay, so I'm sorry, 3i. My bad. I think I accidentally looked to the left there. So 2 minus 3i is 1, 0. So the other 0 would be its conjugate, which would be 2 plus 3i. Okay, so now if we were to put this in factored form, we'd write it as x minus 2 minus 3i and x minus 2 plus 3i. Then we have to multiply those together. So set it up as a 3 by 3 grid. So we have these two. It doesn't matter where we put the 2x minus 2 minus 3i. We could put that on either side, just as long as then we put the other one on the other side. We don't mix the terms up, so they're not interchangeable, but we can put the factors on either side. And now let's multiply these together. So we get x squared minus 2x minus 3ix. We have minus 2x plus 4. And then here you should have had a positive 6i. Then bottom row, we'd have 3ix minus 6i, and then minus 9i squared, which I squared is negative 1, so negative 9 times negative 1 would really be a positive 9. So we want to make sure that we add those together. I like to circle those only because when I go to combine my like terms, I don't make a mistake and forget to add the 9, because you will lose points if that happens. So to get this in standard form, we start with the x squared. There's no like terms there. The negative 2x and negative 2x, remember we would add those together, so we get negative 4x. And then this time we have 4 plus 9, which would be 13. It's positive 13. So there's your answer in standard form. All right, so before we get to the next step, I want to review something that we talked about in the previous video. And if you didn't catch this, make sure that you have this written down in your notes. So remember we talked in the previous lesson, we said the degree of the polynomial in standard form indicates the total number of zeros, both real and non-real. And then we talked about the fact that, so again, there's these two categories under complex numbers or total number of zeros. We would have real numbers and non-real numbers. And then underneath the real numbers, we have two categories, two family types of numbers, rational and irrational. So remember, rational numbers are numbers that can be written as fractions, where the numerator and the denominator would be real numbers. And irrational numbers, those would be, if they are a fraction, if you were to simplify it, it would be like square root of 2 over, and the reason why I say that is square root of 2 over 3, technically you could write that as a fraction, but if you type that in or your calculator, you're going to get a really weird decimal where it just keeps going on and on forever, doesn't ever terminate, and there's no pattern to it, just like pi. Okay, so that's what it means by rational and irrational. But let's focus on rational numbers. Okay, so these can be written as fractions. And we have a theorem that will help us identify all of the possible rational roots or all the possible rational zeros. And that's what we call the rational root theorem. And the key is it gives us the possible rational roots. So those that could be written as fractions. Again, this is not going to be that it gives you what they actually are, but just, whoops, it just gives you what the possible ones would be. So let's see what it means by this idea of P over Q. P is a factor of the constant term. Remember, the constant term is the number that does not have a variable. Q is a factor of the leading coefficient. Okay, so we're going to list out the factors of P and the factors of Q. Now, I really don't care that it's a negative 4. I'm just going to look at it as being 4. And the factors of that would be plus or minus 1, plus or minus 2, and plus or minus 4. How do I get that? Well, I'm just looking for all the numbers that divide evenly into 4. And so or you can just think of the factors of 4. So I know 1 and 4, 2 and 2. You can list them in any order. I like to put them in order from smallest to largest, though. But these would be all of the factors of 4. And the reason why we have plus or minus, because negative 1 times 4 would be negative 4, or positive 1 times negative 4 would be negative 4. So that's why we have to list them out as positive or negative for every single one of those. Okay, so now let's look at the factors of Q. So Q is, again, the leading coefficient, which is 8. So we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, because those are all the numbers that divide evenly into 8, or they're the factors of 8. And so now we're going to look at this as being, we're going to write these as ratios of P over Q. Now what I like to do is I like to do start with Q in my denominator. So again, we're looking at these. We can't just write this as a denominator and just say this is our answer. Okay, we have to list out all of the fractions. So I like to just pick one number to have in the denominator. It's the easiest one to be 1. So if we have 1 in the denominator, these would be in our numerator. So we'd have plus or minus 1 over 1, which is 1. Plus or minus 2 over 2, which is just 2, and so on. Okay, so now we're going to go to the next number that we have in our denominator, which would be 2. So we'd have plus or minus 1 over 2, which is 1/2. Now 2 over 2 simplifies to be 1, so we don't need to list that again. And 4 over 2, that reduces to be 2, and we already have that one listed. Okay, so we're done with having 2 in our denominator. Let's go to 4. So we'd have plus or minus 1/4. 2/4 reduces to 1/2. 4/4 reduces to 1. So again, if they reduce to be something that you already have listed, you don't have to list it again. So now let's look at the last number that we'd use in our denominator, 8. So we'd have, whoops, I already have the plus or minus down. So we'd have plus or minus 1 over 8. And then 2 over 8 reduces to 1/4. 4 over 8 reduces to 1/2. So these are all of the possible rational roots. Now on the test and on the quiz, we're going to have you test one of them because we want to figure out, without using a graphing calculator, how can we figure out if it's an actual 0? So technically, if you wanted to do this without a graphing calculator, we'd have to test, and if we wanted to find which ones are actual zeros, we'd have to test every single one of these, including the positive and the negative. So you see that there's 6 numbers, so technically that means that there's 12 numbers to test. And what does it mean by test? That means that we'd put it in here every time we see an X. But we're just going to do that for, like I said, we're just going to do that for one of these. So let's just pick any number. Doesn't matter which one we use. I'm guessing a lot of you guys are going to say, well, let's pick the easiest one. Let's pick 1. All right, let's go ahead and pick 1. So we'll put 1 into the function. I guess it's function P, so I guess I'll just be consistent and call it function P. Okay, so we'll put 1 into function P. We'd have 8 times 1 to the 5th minus 32 times 1 to the 4th plus 1 squared minus 4. Now this might be easy enough to do without a calculator, but let's do this on our calculator. So I'm going to go to a calculator screen. So again, we're going to type that in exactly as you saw it in our notes. We do 8 and then in parentheses 1 and then to the 5th power. Make sure you arrow over. And then we're going to go minus 32 and then in parentheses 1 again. And this is to the 4th power. Arrow over to get the cursor back down again, and then plus 1 squared, so put 1 in parentheses and then square it, and then minus 4. So we do that, we get negative 27 as our answer. What does that mean? That just means that 1 is not a 0. How do we know if it's a 0? That means we get 0 as our answer. So if you wanted to, you could test another one, but I'm just going to show you. Let's say we wanted to do this again, but try a different number. Notice what I just did there. I hit the up arrow twice, and then I hit enter, and it copied it down here, so now I can edit it. What if we had used 4 as our 0? See that when you do that, you get 12 as your answer. Okay, so I'm just showing you that if you needed to test more than one point, you don't have to retype the entire equation. Or if you ever, like if you catch that you made a mistake, like let's say if you, because one mistake that people will do, instead of using a minus sign, they use a negative sign. Okay, so if you get a weird answer, and like even look at what it did here after I typed that in, it changed everything up here. So if you get something that looks weird after you hit enter, recognize that mistake and then fix it. Okay, so that's how you can always edit it. All right, so let's go back to our notes though. I want you guys, so again, just to review what we did before we have you guys try this one on your own, I want you guys to find all the possible rational roots. So remember the p-value we don't get from the beginning. Okay, that is the one most common mistake. The p-value you get from the constant. The q-value, the denominator, are the factors from the leading term. So make sure that you don't do it in order from left to right. We go from right to left again for this. So, oh, by the way, so before we go to the next example, I'm going to change this one because I really don't like this example. This is just too ugly. So let's change this to be this function. We'll use 2x to the fourth plus 12x cubed plus 14x squared minus 12x minus 16. All right, so pause the video. Using this polynomial, I want you guys to find all of the possible rational roots. And then after you do that, go ahead and pick one to test. And write down what answer you get when you tested it out, and then make sure you understand what that means. And we'll talk about that maybe when you go and check your answer. So go ahead, pause this video and hit play when you're ready to check to see how you did. All right, so let's start from the beginning. So first off, our p-values, like we said, we use the constant, which is 16. So factors of 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. So those are all the numbers that divide evenly into 16. So again, we get that from the constant term, the number on the very end. Now let's look at our values for q, which would be from the leading term. This would just be plus or minus 1, plus or minus 2. So when we look at the ratio, what we could get for p over q, so these, we have all of our possible numerators, but let's start with 1 in our denominators. We have plus or minus 1 over 1, which is just 1, and then 2, and then 4, 8, and 16. So all of those have 1 in the denominator. So now let's just look to see what we have when we have 2 in our denominators. We'd have plus or minus 1/2. Now watch what happens. 2 divided by 2 is 1, we have it. 4 divided by 2 is 2. 8 divided by 2 is 4. 16 divided by 2 is 8. So those are all the possible rational roots. Okay, so when it says what are all the possible ones, that's what we would say. Doesn't mean that they all work, just that those are the ones that there's not going to be any rational roots, there's not going to be any x-intercepts for that polynomial if we were to graph it, that would not be listed there. Okay, so that's why we say that that's all the possible rational roots. Then let's test one of them. Okay, I'm guessing if you kept it simple, you probably might have tried 1. And if you tried 1, you would have gotten 0 as your answer. So what does that mean? That means that 1 is a 0. Okay, so if you got 0 as your answer, that means 1 is a 0. Some other ones that you would have tested or might have tested that would have given you 0 as an answer. If you tested -1, that would have given you 0 as an answer. If you would have typed in -2, you would have gotten 0 as an answer. Or if you would have typed in -4, you would have gotten 0 as your answer. Any other ones you would have typed, you would have gotten numbers that would not be 0. And if it's not 0, then it's not a 0 of the polynomial. It's not a root. It's not an x-intercept. All right. So go ahead and with that, go ahead and start working on your assignment for lesson 3.6.